Hey guys, we're going to continue in this video with our trig functions table. So in the first part, we figured out how to get all of these values. And now I'm going to just write out what you need to do to get the answers for all of them. All right, so you can perhaps on your page, if you have extra space, then add a column on the side that says like right here that says how to memorize, and then just fill them in as you go along. Or what you can do is underneath this table write how to memorize as your title, and then just go sine, cosine, tangent, cosecant, secant, and cotangent all the way down, and then just write in the rules as I tell you. Alright, so there are a couple of ways to do this, and I'm going to actually erase my title because we know what we're talking about in this video. So I can show you a few different things. Alright, so the first thing, I'm going to actually get rid, because hopefully you should have all of these written down by now. If not, go back and copy them all. But I'm going to erase the cosine line down, and I'm going to leave just the sine line there. Alright, because I need this space to tell you how to memorize them. Okay? So if I erase like this. Alright, so the cosine line is basically just the sine theta line backwards. That's the easiest way to figure this out. Alright? Now, the tangent line, we talked about it being the sine numerator divided by the cosine numerator. So, even whole numbers, you can write them as fractions, right? 3 is the same thing as 3 over 1. So 0 is the same thing as 0 over 1, you could say. So it's still, you can still treat this 0 and this 1 as numerators. All right? Now, so for tangent, it's the sine theta numerator, which is the top part of the fraction, don't get that confused, divided by the cosine theta numerator for that particular angle. All right, so if you're working with tan 30, you're going to take sine 30, look at its numerator, cosine 30, look at its numerator, do the sine numerator divided by the cosine numerator, and you've got your tangent value for 30 degrees. All right, now cosecant is the same thing as 1 over sine theta. That's what cosecant is in the context of our triangles and our trigonometric functions. It's just the sine theta value flipped over. So instead of doing opposite over hypotenuse, it's hypotenuse over opposite. So you just take your sine theta line flipped upside down. Okay, and basically you just take your sine line and you flip it upside down. Now just remember, so when you have 1 over 2 and you flip it upside down, you get 2 over 1, which is just the same as 2. When you flip 1 over, you keep 1, nothing happens. When you flip 0 over, you get undefined. All right, and it's the same vice versa. If you take 2 over 1 or 2 and you flip it over, you get 1/2. 1, nothing happens. And if you take undefined and flip it over, you get 0. All right, now you don't actually need that information really, because the only thing you actually need to flip over is this 0 up here, and that gives you undefined for the first value down here. All right, now this one you could flip over the cosine line, or you could do the cosecant line, the line just above it, backwards. So it's the cosecant theta line backwards. All right, and the last one, initially what I did was I flipped over the tangent line, but as you saw at the end, it's actually even easier than that. It's the same thing as the tangent line backwards for cotangent theta. All right, so you can just say it's the tan theta line backwards. Okay? So those are the things you need to remember, and these rules, particularly the zero and undefined thing, otherwise you're going to run into a little bit of trouble there. And maybe what I'll do after this is just to show you that it can be done. I'll make a quick 1-minute video of me going through the table, and I'll walk you through the whole thing so you can see sort of the thought process with it. Now the last thing is, this sine theta line at the top, you need to memorize this. You need to memorize this sine theta line at the beginning, but it doesn't really have much of a pattern to it. It's 0, then it's a half, then it's 1 over root 2. Okay, it's got a square root sign at the bottom. Then it's root 3 over 2, so you don't have a square root on the bottom, but you do on the top. And then you've got 1. It's kind of difficult to figure it out. If you notice, I can't explain why I'm starting with it the way I am, but I'll show you the pattern that there is to it. Okay? So here we could say there's a denominator of 1, 0 over 1, and at the end you could say there's a denominator of 1, 1 over 1. All right? Instead of keeping a denominator of 1, I'm going to make the denominator the square root of 4. Okay? Now we know the square root of 4 is 2, right? 2 squared is 4, so the square root of 4 is positive or negative 2. All right? Now if I make the square root, if I make the denominator the square root of 4, well, let's see, here it's 0 is just 0, so I've got 0 over the square root of 4. This answer at the end is going to be 1. In order for me to get 1, I need to have the same thing top and bottom. So this is the square root of 4 on top. All right, maybe I'll, just for fun, I'm going to make this the square root of 0 right here. All right, now here, 2 is the same thing as the square root of 4, so I haven't actually changed anything. All I've done is I've rewritten 2 in a different way. 2 is the square root of 4, so I can't multiply or divide 1 by anything. The only thing I can really write it as here is the square root of 1. And maybe now you're seeing the pattern. Here, let's do this one first. 2 at the bottom, square root of 4. I haven't really changed anything, and I can't rewrite the top in many different ways, so I'm just going to leave it the way it is. The square root of 3 divided by the square root of 4. And I think you can guess what this last one is. If you take something divided by the square root of 4 is equal to 1 over the square root of 2. So this thing over here, something divided by root 4, is this bit up here. 1 over the square root of 2, we know that's the answer. Now, the square root of 2, to get from the square root of 2 to the square root of 4, you have to multiply by the square root of 2. Just take my word for that if you're not sure. So if I multiply 1 by the square root of 2, well, that's just 1 times anything is going to be that something, so I get the square root of 2. So this might be a helpful way for you to memorize the sine theta line. And if you want, you can write this up here. You can write this bit in place of these numbers on your exam. All right, so you can write, you don't have to write 0, you can write root 0 over root 4. This is the pattern. Root 0 over root 4, root 1 over root 4, root 2, root 3, and root 4. So that's the pattern that gets you these answers down here. They've just cleaned it up a little bit. They've made it in the kind of the simplest way that you could write it. Okay, so that's how you memorize those sine theta values. And then as you can see, everything else you can either get directly from the sine theta line, or a combination of those things, or one of the other lines that you've got from the sine theta line. All right, so once you memorize this top line, you can fill out the entire thing. Now we've got 5 minutes left in this lesson, so I'm going to do something that we've sort of talked about, and it's related to trigonometry. It's called Euler's Formula. All right, now it's not something that you're going to need to use at this stage in your lives, but it might come in handy someday. Now, just to review, Euler's formula is written as follows: e to the exponent I pi plus 1 equals 0. All right, now the thing that makes this special is that you don't need to have pi here. The basic form is to have a theta there, e to the exponent of I theta. Remember, I is the square root of -1. It's the unit, imaginary unit, all right? So e to the I theta is actually, it's got a formula that's rooted in trigonometry. E to the exponent I theta is actually the same as cosine of theta plus I multiplied by sine theta. All right? Now, if I, instead of having a theta here, if I plug in pi instead of theta, e to the I pi, I get cosine of pi plus I times sine of pi. All right? Now here's the thing. Pi, cosine of pi, you might think, well, that's not cosine of 3 degrees, that's cosine of 3.14 degrees. There's a little bit of a catch. This is not in degrees. This is written in sort of an alternative measurement of angles known as radians. All right? Now basically, you don't have to worry so much about what a radian is. Right now, that's sort of beyond the scope of this class. But in a full circle, if you go all the way around in a circle, that's a pretty terrible circle, but don't worry about it. If you go full circle, that distance that you cover in degrees is 360 degrees. All right, this, by the way, is not going to be on your exam. The same thing, the same 360 degrees, if you measure it in radians, the distance all the way around is 2 pi radians. All right, so that means, well, if you go all the way around, that's 360 degrees. Let's say I only go halfway around. Let's say I only go up to here. All right, let's say I only go up to there. Well, then that is 360 divided by 2, that's 180 degrees. We already hopefully know that. If I do the same thing here, I only go this far, well then instead of going all the way around and getting 2 pi radians, I go halfway around and I get pi radians. Okay? Now, so that means that pi radians, so pi radians is equal to 180 degrees. Okay? And you can actually use this to figure out what a radian is. A radian is 180 degrees divided by pi. Right? And it's about 57 degrees, I think. So pi radians is the same thing as 180 degrees. So let me, instead of pi down here, just because we haven't worked with radians, I'm going to put 180 degrees here and 180 degrees here. Now at this point, you can make use of the unit circle that we talked about in our previous lesson. So basically, if you draw, a line like this, and then you sort of craft a triangle out of it, the coordinates of this point are cosine theta, sine theta, and it's a circle with a radius of 1 unit. All right, so if I draw that line out over here, 180 degrees from the positive x-axis, remember the positive x-axis is always in that direction, and I draw, instead of just somewhere between 0 and 90, I draw all the way to here. So I make my line right here. Well, that means my point is over there. I've gone 180 degrees, and the coordinates of the point should tell me what cosine theta and sine theta are. Well, if the radius of the circle is 1, that means my cosine 180 degrees value is going to be, well, 1 unit in the negative direction. So cosine of 180 must be -1. And I haven't gone up off the x-axis. This point is resting on the x-axis, which means that sine of 180 degrees must be 0. Okay, so what this tells you is that cosine of 180 is equal to -1. So cosine of 180 degrees is equal to -1. And then when you multiply I, even though it's a special number because it's imaginary, if you multiply it by 0, sine of 180 is 0, I times 0 is 0, so you just have nothing. So you've got e to the I pi equals -1. That's what we've got here. And just to finish this off really quickly, if you've got e to the exponent I pi equals -1, well, I don't want a -1 on that side, so let me just add 1 to both sides of the equation, and I get e to the I pi plus 1 equals 0. And this right here is Euler's formula. Alright, you don't need to know this for your exam, but you do need to know the trigonometry table that was just before this. This was just for those of you that were asking about this a couple of months back. So hopefully this all made sense. You remember that you will have a quiz on that trig table on Tuesday, May 14th. Alright, and then we will do an exam breakdown after that. See you then.